Alright, so we're going to do question 8.13. So this is a perfect complement case, and I'm going to show you how to find the optimal bundles for this special case. Okay, so now remember, this is not a well-behaved reference in which it's not possible to equate the slope of the indifferent curve and the slope of the budget constraint to find the optimal bundles. Okay, so an easiest way to do is to so what you have to do is to look from the graph, and then I'm going to show you a way to find the optimal bundle. Okay, so part A of the question asking you to sketch the indifferent curves for a utility level of 10, 15, and 20. Okay, and then indicate the most preferred affordable consumption bundle on the diagram. Okay, so first of all, we want to draw an indifferent curve for the utility level of 10. So what we do is we just going to equate our utility function, which is a minimum between 2b and 3c, to 10. Okay, so any bundles B and C that are satisfying this equation are going to be on the indifferent curve corresponding to level of utility of 10. Okay. Alright, so how do we draw the indifferent curve for this case? So basically we do not know the values of 2b and 3c's. Okay, so we have three cases to explore. So the first case is where 2b is smaller than 3c. Okay, so now if that's the case, then the minimum between 2b and 3c is going to be equal to 2b. Okay, because 2b is smaller. And so if we want to equate that to 10, then that is going to be corresponding to b equal to 5. Okay, so this is the case where b equal to 5, and so therefore 3c, it has to be bigger than 2b, which is 2 times 5 equal to 10. So therefore c, it has to be bigger than 10 on 3. Okay, so any values of b equal to 5 and c is bigger than 10.3 is going to give the consumer a utility of 10. So any bundle with b equal to 5 and c is bigger than 10 on 3 is going to be lying on the indifferent curve with a utility level of 10. Okay. Okay, so I will say any bundle would be equal to 5 and c is bigger than 10 on 3. Okay, is on the indifferent curve with the utility level of 10. Because as you can see, b equal to 5, 2b is going to be equal to 10, and c is bigger than 10 on 3, then 3c is going to be bigger than 10. So therefore the minimum between these two is going to be equal to 10, which is what we want. Okay. Now, so the second case is where 2b is bigger than 3c. So therefore our utility function, the minimum between 2b and 3c, is going to be equal to 3c. Okay, because 3c is smaller. And we want our utility to be equal to 10, so I equate that to 10, and so therefore c equal to 10 on 3. Okay, and we want 2b to be bigger than that, so 2b is going to be bigger than 3 times c, which is 10 on 3, which is equal to 10. So therefore b has to be bigger than 5. Alright, so I would say any bundle with b bigger than 5 and c equal to 10 on 3 is going to be on the indifferent curve with utility level of 10. So all of these bundles are going to be on the same indifferent curve. Okay, and so the third case is where 2b equal to 3c. Alright, if that's the case, then the minimum between these two would just be equal to 2b, and that just equal to 3c. And if I want to equate that to 10, then I should be able to find that b equal to 5 and c equal to 10 on 3. Okay, so this bundle over here is going to be on the indifferent curve of 10, of utility level 10 as well. Okay, so b equal to 5, c equal to 10 on 3. is going to be on the indifferent curve with a utility level of 10. Okay, so we got all of the bundles that we want. Okay, that's basically covering all of the cases. So therefore now I'm just going to draw that on a diagram. Okay. Alright, again I would have C on the vertical, I have B on the horizontal, and I have 0 over here as origin. Okay, so I got I'll just say I got 5. Okay, so 1, 2, 3, 4, 5. Okay, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. Okay, so that is 10. That is 5, and that is 15. Okay, and on the vertical I will have again just 5 on 3, 10 on 3, 15 on 3, 20 on 3, okay, 25 on 3, 30 on 3, which is 10. This is just 5. Okay. Alright. Okay, so the first thing is we're going to plot this bundle where B equal to 5 and C equal to 10 on 3. So 10 on 3 is here, and 5 is going to be here. Okay, so that's the first bundle that is lying on an indifferent curve. Now the second one is where, so any bundle with B equal to 5 and C is bigger than 10 on 3. So B equal to 5, which is here, and C is bigger than 10 on 3, which is from this point onward, going all the way up to the vertical. Okay, so at the same level, B equal to 5, any C is bigger than 10 on 3 is going to be on the same indifferent curve. So having said that, that is basically the straight line going all the way up, including any bundle with B equal to 5 and C is bigger than 10 on 3. Okay, so any of these bundle along the vertical line. Okay, and the second case is where any bundle where C equal to 10 on 3 and B is bigger than 5 is going to be on the same indifferent curve as well. So C equal to 10 on 3, which is here, yeah, and any B is bigger than 5, which is to the right of this point, they are going to be on the same indifferent curve. So if I got a horizontal line going all the way from this point, which is any B bigger than 5, at C equal to 10 on 3, is going to be on the indifferent curve. So we know that this is the indifferent curve for the UT level of 10. Okay, as you can see, this is an L-shaped curve, which is the normal indifferent curve for a perfect complement case. Alright, so we are going to do exactly the same thing for a UT level of 15 and a UT level of 20. Okay, so U15, then we are going to have the minimum between 2B and 3C equal to 15. Alright, so again, the first case is where outside 2B equal to 3C, and so therefore the minimum between 2B and 3C is just going to be equal to 2B, and that is just going to be equal to 3C, because these two values are equal to each other and equal to 15. Okay, so therefore B equal to 5 and C equal to B equal to 7.5 and C equal to 5. Okay, so second case where 2B bigger than 3C, then the minimum between 2B and 3C is just going to be equal to 3C, okay? And that needs to be equal to 15, so C equal to 5, and we want 2B to be bigger than 3C, which is 3 times 5, which is 15, so therefore B we want to be bigger than 7.5. Okay, so any bundle with C equal to 5 and B is bigger than 7.5 is going to be on the indifferent curve corresponding to the utility level of 15. Okay, and the last case where 2B is smaller than 3C, then okay, the minimum between 2B and 3C is just going to be equal to 2B, and that has to be equal to 15. So B will be equal to 7.5. Okay, and we also want 3C to be bigger than that, which is 2B, and B equal to 7.5, so that is 15. So therefore C, it has to be bigger than 5. Okay, so anything with B equal to 7.5 and C is bigger than 5 is going to be on the indifferent curve with a utility level of 15. Okay, so any bundle. Okay, so this including all the bundles that are on the same indifferent curve. Okay, so in terms of a diagram, we're just going to do that again over here, where the first bundle is on the indifferent curve is B equal to 7.5 and C equal to 5. So C equal to 5 is here, B is 7.5, so that is somewhere here in the middle. Okay, so alright, so that's just the point over here. Alright, and the second part is where any C equal to 5 and B is bigger than 7.5. So as you can see, any point to the right of this point with the same value of C equal to 5 and B bigger than 7.5, it is going to be on the same indifferent curve, so that it's just the horizontal part to the right of the point here. Okay, and again the last case is any point where B equal to 7.5 and C equal to 5. So C equal to 5, B equal to 7.5, which is here, and C is bigger than 5, so that is just going to be the vertical part. Yep, going all the way up. Okay, so this is the indifferent curve corresponding to the U of 15. Alright, so the last case where U equal to 20, again just the minimum between 2B and 3C equal to 20. And so if I equate 2B and 3C equal to 20, then I got B equal to 10 and C equal to 20 on 3. Okay, so that is B equal to 10 and 20 on 3 is here. Okay, so this case I'm going to do it quickly, so I'm not going to go through all the steps anymore, so you can just follow exactly the same step as what we did before. Okay, so we got the point. Then if you are doing just exactly the same as what we did, alright, so I'm going to connect these point up to here. Alright, so then I got this is the indifferent curve corresponding to the UT level of 20. Alright, so indicate the most preferred affordable consumption bundle given that M equal to 150. Alright, so to find the optimal consumption bundle, we need the budget constraint. Okay, so in this case, we are given the prices, PB equal to 10, PC equal to 15, and the income equal to 150. So therefore, our budget constraint is 10B. Okay, plus 15C is equal to 150. Alright, so I'm just going to draw this on a diagram. So this basically just a straight line with a horizontal intercept of, so if I make C equal to 0, I know that B equal to 15. So this is my horizontal intercept. And vertical intercept is where I make B equal to 0. I know that C is going to be equal to 10. Okay, so C equal to 0, B equal to 15, which is here, and 10, which is here. Okay, so that is my budget constraint line. So if I connect these 2 points together, I'll get my budget constraint. Okay, so this is my budget constraint. Now, so I want to find a point on this budget constraint that is lying on the highest indifferent curve, because I want to find the most preferred affordable bundle. Alright, so what is going to be on this red line? So what bundle on this red line should we pick in order to be on the highest indifferent curve possible? So should I pick this point over here, for example? Now if I pick this bundle over here, as you can see that it is on the budget constraint, which is good, okay, which is affordable. Now it is corresponding to an indifferent curve of utility 10. Okay, so as you can see, this bundle here on the indifferent curve ICU 10. Is it the best we can do? Okay, now if we are choosing this bundle over here, for example, what would be the utility corresponding to this? So if you draw an indifferent curve going through this bundle over here, you can see that it is going to be something like this. Okay, so it's going to be something like that, corresponding to this bundle. Now this bundle over here corresponding to this ICU 10. So if you keep doing that until you get to a bundle such that you achieve the maximum utility or the highest indifferent curve, then that is going to be the optimal point. Remember, the further away from the origin, the higher the utility. Okay, so the direction of increasing utility is going this way. Okay, so the higher the indifferent curve, the higher the utility, as you can see. So this utility of 10 is lower than this indifferent curve for utility of 15, and lower than the indifferent curve for utility of 20. Okay, so the further away from the origin, the higher the utility. So as you can see, this bundle over here is going to be the bundle on the budget constraint and lie on the highest indifferent curve, which is indifferent curve utility of 15. Now you will not be able to find any bundle that is better than this bundle, because if you pick somewhere else that is higher than this utility, then it's not going to be on a budget constraint anymore. So for example, someone is asking, okay, why can't I pick this bundle over here? Because it's on the indifferent curve of utility 20, which is higher. Now as you can see, it's not on a budget constraint anymore, so it's not affordable. Okay, so this is going to be the affordable and most preferred bundle because it's lie on the highest indifferent curve possible. Okay, so as you can see, this is basically the intersection between so basically the tension between the indifferent curve and the budget constraint. Okay, so one rule to remember is that the optimal bundle for the perfect complement case is always going to be on the vertex. It's going to be the vertex point, the kin point. Okay, that is touching the budget constraint. All right, so the optimal point is the kin point, and it is on the budget constraint. Okay, so that is the preferred bundle. Okay, so the optimal bundle is where B equals 7.5 and C equal to 5. Okay, now part B asking you if the price is in the PC increases to 20, show the change in demand. Okay, so if I got PC now equal to 20, so the only thing changed is my budget constraint. Everything else remains the same. Okay, so PB remains the same, 10B, and PC become 20C, and that equal to 150. Okay, So I just have to draw this budget, the new budget constraint BC2 on a diagram. So my horizontal intercept is where I make C equal to 0, so therefore B equal to 15, which is the same as before. Now vertical intercept is where I make B equal to 0, so C is going to be 150 divided by 20, so that will be 7.5. So my new budget constraint, I'm going to use a blue line to draw it, and that is on the same horizontal, but say 7.5. So I got 5 over here, I got 10 over here, so 7.5 would be somewhere in the middle, which is here. Okay, so this is my new budget constraint. I'll call this budget constraint 2. Alright, so now what would be the optimal bundle in this case? So again, I would just have to find the most preferred bundle that is lying on the highest indifferent curve and also on a budget constraint. Okay, so for example, if I pick this bundle over here, it's going to be corresponding to the red indifferent curve. I pick this bundle over here, it's going to be corresponding to an indifferent curve util 15, okay, etc. Now, what is going to be the best point that I can get? Again, like I said, it is going to be the tension between the indifferent curve and the budget constraint. Okay, so therefore, if you pick a bundle such that it is the intersection between the vertex point of the indifferent curve and the budget constraint, that is going to be optimal, because you would not be able to find anything better than that. Okay, so for example, if I pick a bundle over here, okay, now corresponding to this bundle, this is going to be the indifferent curve. Okay, then this bundle over here is going to be the optimal bundle in this case. Now the reason is because it is lying on the highest indifferent curve possible. Okay, now if you pick this bundle over here, for example, okay, then corresponding to that is going to be this indifferent curve here, which here again, as you can see, is lower than the indifferent curve IC star that we have. Okay, so this indifferent curve IC star, which is the indifferent curve such that the vertex point is touching the budget constraint, is going to be the highest indifferent curve you can get, and so therefore this is going to be the optimal bundle. Okay, so to find that optimal bundle, what we have to do is to find the vertex point of the indifferent curve that is touching the budget constraint. Now, so the rule is, we know that the vertex point or the kin point, okay, is the point at which the two values in the utility function is going to be equal to each other. Okay, so as you can see, every time we equate 2b and 3c, then we can find, and then that is going to be the kin point, okay, on the indifferent curve. So if I equate 2b and 3c, then this is going to be the equation that is including all of the kin bundles. Okay, so then I say this is the equation, okay, for all of the kin bundles. Okay, and so therefore now we just have to find a bundle that is satisfying this equation, okay, and also lying on the budget constraint over here. Alright, so in order to do that, if I substitute the 2b equal to 3c, okay, into my budget constraint 2, which is 10b plus 20c equal to 150, then I get so I got over here B is just going to be equal to 3 on 2C. So I have 10 times B, and B is just equal to 3 on 2C plus 20C, and that has to be equal to 150. And so therefore I got 15C plus 20C equal to 150. So I got 35C equal to 150. And so therefore C is going to be, sorry, I just have to use a calculator. 150 divided by 35, that will give me, sorry, so divided by 5 will give me 30 on 7. Okay. Okay, and now in the values of C, I should be able to find B, which is 3 on 2 times C. And so that is 90 on 14, 45 on 7. Okay, so this is the value of B and C, which is optimal given the new budget constraint. So I just have to indicate that on the diagram, which is here. Okay, so this point over here corresponding to a B of 45 on 7. Okay, and over here it's just 30 on 7. Alright. Okay, so we are basically moving from the red bundle to the blue bundle over here. Okay. Okay, so part C asking you to illustrate the income expansion path on a diagram and the total effect of the price change. So we know that the income expansion path is just basically the line or the curve that is containing all of the optimal bundles. Okay, so as income varies. So in this case, we know that the equation for the optimal bundles is going to be the equation for all the kin bundles over here. Okay, so this is the equation for all the optimal bundles, because we know that the optimal bundle has to be the vertex point, or it has to be the kin bundles. Okay, so therefore this is the equation for the optimal bundles. So as income increasing or income varies, any point along this line is going to be optimal. Okay, so therefore the income expansion path in this equation, in this case, it's just going to be the equation where 2b equal to 3c. Okay, and that is just going to be the line that connecting all the vertex point in our diagram. So if I use a straight line and green color, and I connect all of these vertex points together, okay, then this is going to be the income expansion path. Okay, so this is basically including all the optimal bundles, and depending on the level of income, we are going to have a different bundles. Okay, so as you can see, now we are moving from the red point to the blue point. Okay, and that is moving along the income expansion path, which is basically telling you that the change in the demand is basically purely due to the income effect. So as we move from the red to the blue bundle, we are having a decrease in the income, okay, because the price of wood C is now higher, therefore the purchasing power is lower, and so therefore it's reduced the income, reduce the income power, right? And so therefore we have a reduction in income, and so therefore we have a decrease in the demand for both the goods due to the income effect, because we are moving along the income expansion path. Okay, so the income expansion path is telling you how the optimal bundles are going to be different as we have an income change. So in this case, we do not have any substitution effect, because the move is purely on the income expansion path, which is basically telling you that the change in demand is purely because of the income effect. Okay, so we're moving from the red point to the blue point because we have a lower real income or a lower purchasing power due to an increase in the price of goods. Okay, so therefore I conclude here. Okay, so the total effect of the price change in this case, so the optimal bundle move from the red bundle to the blue bundle along the income expansion path. Okay, so the change in demand is purely due to the income effect, and there's no substitution effect. Okay, so if I want to show you that on a diagram, it's pretty straightforward. So as you remember what you studied from the lecture, in order to show the in order to show the substitution effect, what we do is we draw a substitution budget constraint, which is a temporary budget constraint that is parallel to the new budget constraint to reflect the increase, to reflect the change in price. However, still going through the original, still keeping the consumer at the same level of utility, or going through the same original bundle. And we want to see with that temporary budget constraint what is going to be the new consumption bundle, and that is going to show you the substitution effect. So in this case, if I want to draw a very temporary budget constraint, that is going through the original bundle and parallel to the new budget constraint, which is the blue line, then that is going to be somewhere here. So if I draw a budget constraint that is parallel to the blue line and going through the original consumption bundle, red bundle over here, so I call this is the temporary, or in the textbook it is called the substitution budget constraint. So and I want to find the optimal bundle under this temporary budget constraint. Now, as you can see, for this budget constraint, the optimal bundle again is still going to be the red bundle, which is the intersection between the vertex point of the indifferent curve and the budget constraint. Alright, so that confirms that there is nothing change if we are moving from our red budget constraint to a temporary budget constraint. So therefore there is no substitution effect, because the consumer is still going to consume exactly the same bundle under the temporary budget constraint, and this budget constraint is basically the constraint to show the substitution effect. It's reflect the new price, and we would like to see whether the consumer changed their behavior because of the new price. In this case, as you can see, the consumer is still going to consume exactly the same red bundle as before, given the new price. So therefore there is no substitution effect, and the only effect that is causing the consumption bundle to move from the red bundle to the blue bundle is the income effect in this case. Okay, so it's purely income effect and there's no substitution effect.